Welcome to this explainer. Today, we're going to do something absolutely fascinating. We are going to decode 3 incredibly complex ways of human thinking. And we're going to do it by looking at something you've probably seen 100 times before, a simple medical fever chart. Get ready because this is going to completely change how you view decision-making. Okay, let's dive into this. Picture a doctor standing right there in a hospital room looking closely at your fever chart. The thermometer reads an exact number. But here is the central question of our explainer today. If that doctor knows your precise temperature at this exact second, do they actually know how to cure you? Well, the answer reveals a massive gap in how we traditionally think about logic. Section 1, the fever curve puzzle. 2 different diseases.
Think of it this way. Temperature isn't the actual illness, right? It's just an outward projection. It's like a shadow on the wall. And look at how vastly different these 2 shadows are. For lobar pneumonia on the left, the temperature hits a high plateau and just stays there, followed by a sudden, cliff-like drop. This is what we call a threshold system. The body's inflammatory response builds up and holds steady until a clearing mechanism triggers, causing a rapid drop. But on the right, mumps presents as a gradual, symmetric bell curve. It's a self-limiting biological process where the viral replication and immune response gradually peak and then smoothly decline. So the exact same temperature can mean vastly different things depending on the underlying shape of the disease. Let's move to and see how this builds. Section 2, formal logic, freezing time, the exact moment.
So when we ask, what is the exact temperature right now, we're using formal logic. Formal logic demands that we take a continuous flowing reality and literally slice it into an exact, static, non-ambiguous moment. In mathematics, this is exactly what finding the instantaneous derivative in calculus does. It doesn't avoid change. It tames change by infinitely slicing it into static pieces that can be judged as simply true or false. You get a statement like, the patient's temperature is exactly 39.2 degrees right now. It's an undisputed, precise fact. But I want to ask you, does this exact dot of information, this single frozen slice of reality, actually tell the doctor what medical action to take next? Honestly, no. A static point, no matter how perfectly measured, is entirely blind to the future.
Section 3, dialectical logic, seeing the shape of the whole process.
Now, what's really interesting about this slide is that dialectical logic couldn't care less about a frozen second. It cares about the momentum, the internal contradictions, and the struggle driving the whole system. It's about how gradual, quantitative changes eventually accumulate into a massive qualitative leap. In calculus, this is perfectly represented by the peak of the second derivative, the exact mathematical expression of a system shifting from one fundamental state to another. Using dialectical logic, the doctor looks at the chart and realizes this is the plateau phase. The internal struggle is peaking before a massive shift. This is incredibly profound. It beautifully explains the why and the how of the disease's process. But notice the glaring issue that still remains. The doctor is left hanging. Understanding the grand process of a disease doesn't inherently tell you what prescription to write.
Section 4, Yili logic, compressing into decision.
Here is the critical missing piece of the puzzle that bridges the gap between knowing and doing. Yili logic is a unique decision logic. It takes the instantaneous facts we got from formal logic, combines them with the deep process understanding from dialectical logic, and compresses them both into an immediate, actionable clinical judgment. Because the doctor is dealing with a patient in a specific phase of a specific disease, Yili logic forces the doctor to actively look for other leading signals, like the patient's breathing rate or sputum color. Why? Because they have to act right now, in the real world. This thought process transforms everything. It goes something like, based on the exact temperature and the disease stage, I must check their breathing right now to adjust medication. Yili logic takes passive observation and actively thrusts it onto the plane of action. It literally forces a decision out of the data. These 3 concepts actually stack together into a beautiful mental assembly line. Step 1, you slice reality into static, exact moments. Step 2, you observe the overall shape and momentum of the change. And step 3, you compress all of that into an immediate action. In fact, calculus itself embodies this exact progression. Isaac Newton's math works so incredibly well precisely because it weaves these ways of looking at reality together rather than forcing them to compete. Section 5, the flaw of pure logic, when the real world hits. So formal logic is brilliant at verifying theories that already exist. If you give it a rule, it can tell you for sure if your data fits, but it cannot spark the initial leap of discovery. Scientific heavyweights like Thomas Kuhn, Karl Popper, and Albert Einstein all fundamentally agreed on this. Einstein famously noted that there's no purely logical path to the discovery of universal laws. It requires a leap of intuition. Formal logic polices the rules. It doesn't invent the game. To truly understand the limits of pure logic, think about the number one. The famous philosopher Karl Popper claimed that to logically disprove the theory that all swans are white, you only need to find exactly one black swan. Pure, elegant, formal logic, right? Well, let's look at what that actually entails out in the wild. And this brilliantly illustrates by finding that single black swan isn't just a chalkboard exercise. It's a brutal physical act bound by real-world constraints. You need the information to know that black swans might be in Australia. You need the money to buy a boat ticket. You need the physical health to survive the voyage. You need the time to get there before the species goes extinct. And crucially, you need the motivation to even care enough to check in the first place. This reveals the hidden, flawed assumption of relying only on pure formal logic. It assumes an ideal observer, a theoretical philosopher with unlimited time, unlimited resources, and perfect information, hunting for absolute truth. But our doctor? The doctor is a real actor. They're working with incomplete information, severely limited resources, and most importantly, a ticking clock. When a patient is crashing, time itself is a desperately scarce resource. The doctor cannot wait for perfect logic. They must act. Section 6. 3 logics, 1 picture. The assembly line. So the crucial point is that these 3 logics are not competitors. They are specialized tools in a 3-part assembly line. Formal logic is responsible for the point, the exact facts. It answers, is it true right now? Dialectical logic is responsible for the line, the entire process. It answers, how and why is this changing? And finally, Yili logic is responsible for the decision, the action. It answers the ultimate real-world question. What do we do next? Without the point, the line is abstract. Without the line, the point is just an isolated fragment. And without the decision, knowing the point and the line doesn't actually help anyone survive. Waiting for perfect information before making a choice isn't just difficult, it's practically impossible in a world governed by time and resource limits. We are all, in our own ways, that doctor looking at the fever chart of our lives, our businesses, our relationships. So I leave you with this final thought to take away from our explainer today. Since perfect information is a myth, what logic are you relying on to make your next move? Are you stuck looking at the dots, or are you ready to compress your knowledge into action?